Calculus Kids, this is Dr. Callahan with week 18 Friday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up vlog. Okay, so this is actually the last day I see you guys before your AP exam. So we're going to start with the very last unit, which is on anti-differentiation and techniques and whatnot. So it looks like this. And we're just gonna go ahead and jump right into the very first question. So we started with semester 2 on Riemann sums and area approximation. So take a moment and read this question here. So this is like a typical question they'll have in the multiple choice. And looking at this, it's saying, what is the right Riemann sum of the 4 different subintervals between those 4 intervals? So I know that's from 1 to 10. And so my f of x dx is going to then equal to, I take a look at this, it is going to be a right, let's see, it's going to be a, okay, right approximation, so it's going to be on the right side. So here's the first one, because that's on the right side, second one, third one, fourth one. Okay, so if this is going to represent height, your base is going to be in between. So 3 minus 1 is a 2, 5 minus 3 is a 2, 8 minus 5 is a 3, 10 minus 8 is a 2. So we just take the base times the height. So 2 times 12 plus 2 times 16 plus 3 times 23 plus 2 times 17. Add them all together using your calculator, and you should have a total of 159. And that is answer letter D. Let's take a look at number 2. So how do you find the integral if it's involving a geometric figure? This is one we have to find the area. Anything above the x-axis is a positive area. Everything below is a negative area. So looking at this here, our first shape that I have is going to be a negative, and this is going to be a triangle. So my base is going to be, that's not my base, that's my height actually. My base is going to be between 5 and 3, so that's going to be a 2. My height is going to be from 0 to 2, so that's going to be 2 as well. So then my first triangle, I'll just put area 1, this is area 1, is base times height times 1/2, but it's a negative, so it's just going to be a -2. Oh, you know what? I got the base wrong. The base is not 2. I was looking at the 3 and the 5, but that 3 is here. The base is 1. Just kidding. So it's going to be a -1. There we go. Next part is going to be this triangle right here. That's my area 2. So my base is going to be between 1, 2. So there's 2 spaces here. My height is up to 2 as well. So then my area 2 is going to be 2 times 2 times 1/2. This one is actually be 2. My area 3 is a semicircle. The radius here looks like it's 2. So that's going to be 1/2 pi r squared. So that's going to be a 4. So that's going to be 4 divided by 2 is a 2 pi. And then my next one is a trapezoid. So the trapezoid, you have 1, 2, 3. So base is 3. So base 1, base 2 is 2. Height is going to be 1. So my area 4 is going to be 1/2 height, which is 1, base 1 plus base 2. So that's going to be 5 over. Oh, it's a negative, so it's going to be a minus. Over 2. So then all together, let's add everything. This part is going to give me a 1. So then a 1 is the same thing as a 2 over 2. So 2 plus that's 7 over 2 plus 2 pi is your answer. All right, so for number 3, you're asked to find the definite integrals with an absolute value. So then remember, it's the same thing as saying at a y equals absolute value of x minus 2, which if you take a look at that right there, remember its absolute value is talking about distance. So you're really looking at the distance from this, and starting point is going to be at 2. So if I were to draw this, here is 2, and I'm going to have an absolute value that looks like this. And the area that I'm looking at is from -3 to 5. So 2, 3, 4, 5. So I'm looking at this area right here in addition to 5. So that's going to be, or -3, 1, 2, -1, -2, -3. So extend that over a little bit. And this area right here. So there's actually 2 ways that you can do this. You can either go ahead and just find the area of it, which I think actually might be the easiest. So if I look at the left triangle here, you have 1, 2, 3, 4. 1, 2, 3, 4, 5. Your base is going to be a 5. Your height, unfortunately, is something that you will have to actually find out for this. But you know when x is equal to -3, what is your height? Your height is going to be -3 minus 2, so it's going to be a positive 5. So your left triangle is 1/2 5 times 5. Plus your right triangle. Your right triangle with the base between 2 to 5 is a 3. Your height at 5, 5 minus 2, absolute value is a 3. So 1/2, 3 times 3. So then 25 over 2 plus 9 over 2 is just going to give you 17. And that's your answer. So it looks kind of like a difficult question, but really it's not that difficult. It's fairly simple for the most part. For number 4, it is asking you to find the integration of cosine t squared. So let's try this. F prime of x is equal to the integral d over dx of 0 to square root of x cosine t squared dt, which is then going to equal to cosine. And if you decide to go ahead and do this as t as in u, so let u be t squared, du is 2t dt. So then dt is equal to 1 over 2 t du. So then when I go ahead and do that, it is going to give me a cosine square root of x squared times 1/2 x to the -1/2. So then if I were to translate it, remember f prime of x equals cosine, or actually, I'm sorry, I put x instead of t. That is totally my bad. I want to go back and change that. T. Okay, so then cosine x times 1 over 2 square root x, which is f of 4, is going to give me a cosine 4 times 1 over 2 square root of 4, which is the same thing as cosine 4 over 2 times 2, which is just cosine 4 over 4. And that's going to give you b. All right, so for number 5, go ahead and try this one on your own for the average value theorem. Number 6 for the first fundamental theorem application. And number 7 for U sub A and B. And if you need some assistance with this, keep in mind that you do have the answers of this right from the beginning on the link right here. And when you're done with that, you can continue on practicing for the remaining part of the unit for integration, except a lot of the questions on the test is going to be on free response. So I just included some of the questions here. I do have the answer right here on this tiny URL, so you're welcome to go ahead and use that. And then in addition to that, I also have the AB calculator solution and no calculator solution for 1998, which you guys can go ahead and click on that or use a tiny URL to access those tests. All right, you guys, as always, I hope you have a wonderful week and I'll see you guys next time. Take care.